Operating the unprecedented scale of the 2026 FIFA World Cup requires engineering and defending a massive continental digital perimeter. This tournament spans 104 matches across the United States, Canada, and Mexico. Venues like Estadio Azteca handle tens of thousands of fans on the ground. This chart illustrates the digital weight of a single match. While a typical large-scale event might use a few terabytes, a 2026 World Cup match generates a 50-terabyte data spike. The tournament acts as a massive temporary supercomputer. Linking 16 separate stadiums across 4 time zones means syncing all that data into one cohesive, pulsing web. Operating a temporary supercomputer at this scale makes the tournament inherently fragile. If the connections between these 16 nodes fail, the entire continental operation collapses, placing the survival of the event in the hands of the network engineers. Every piece of that data flows back to the Technology Command Center in Miami. Inside this heavily fortified room, operators monitor telemetry screens covering the entire tri-national footprint. The back-end server networks and AI infrastructure processing all this information were engineered by Lenovo. Their system, the Intelligent Command Center, continuously ingests thousands of live data feeds. It tracks municipal transit flows, team flight patterns, and crowd density metrics in real time. Using digital twins of the venues, the AI simulates the physical environment to predict pedestrian bottlenecks outside the gates. Organizers can reroute resources before a physical security issue even materializes. Defending millions of attendees depends entirely on maintaining this continuous, continent-wide vision. If the network goes down, the tournament flies blind. To guarantee that network stays active, engineers laid a 7-terabit fiber-optic backbone specifically to transport the live match broadcasts. All 16 stadium feeds converge here at the International Broadcast Center inside the K. Bailey Hutchinson Convention Center in Dallas before being distributed globally. This logic tree shows the extreme physical redundancy required for the transport layer. Each venue pushes 600 gigabits per second of data along 2 primary fiber paths, and each of those paths has 3 backup routes standing by. If a physical cable is severed, the data packets instantly divert to the backup routes. The global broadcast doesn't drop a single frame. This level of redundancy is engineered for more than simple equipment failure or accidental fiber cuts. It is a defensive posture intended to sustain a global broadcast through active, malicious disruption. Almost the exact moment the tournament went live, advanced persistent threat groups began aggressively probing the outer digital perimeter. Iranian-affiliated groups, like Handela, actively scan for internet-exposed Rockwell Automation programmable logic controllers, the exact hardware managing municipal water and energy grids in host cities. Simultaneously, Russian hacktivists such as NoName05716 conduct thousands of distributed denial-of-service attacks, flooding high-profile geopolitical targets with junk traffic to disable services. These state-sponsored operations hit the tournament's networks in continuous waves, specifically designed to overwhelm servers and force systems offline. Financially motivated ransomware syndicates also target the hospitality sector and the teams themselves. In 2024, Italian club Bologna FC suffered an attack that exposed 200 gigabytes of strategic and financial data. And intelligence gathering operations remain a constant risk, following the precedent set in 2022 when Chinese state actors compromised a telecommunications provider during the World Cup. With so many global adversaries converging on a single event, the World Cup functions as a geopolitical proxy war. The most severe threats to the matches are fought in server environments, completely invisible to the fans. The data collection isn't limited to the stadiums and server farms. It extends directly onto the pitch, built right into the Adidas Trianda match ball. This diagram shows a 14-gram inertial measurement unit suspended inside the ball by FemuWire counterweights, acting as edge computing hardware. That chip records the ball's kinetic data 500 times per second, registering the exact millisecond a player's boot makes contact. Above the field, a network of 12 optical cameras tracks 29 separate points on every player's skeleton. The system then fuses that anatomical tracking with the ball's telemetry. This AI sensor fusion generates live 3D avatars of the players, reducing offside decisions to a 10-centimeter accuracy threshold and generating a ruling in seconds. By embedding edge computing directly into the equipment, organizers replace subjective human observation with a rigid, data-driven record of events. Yet, despite the billions spent on fiber optics and edge computing, the most critical failsafe in the Miami Command Center is an old-school analog whiteboard covered in dry erase marker. If the predictive AI fails and the redundant fiber paths are breached, the staff relies on this manual countdown protocol to keep the tournament functioning. The 104 matches of the 2026 World Cup are the visible layer of a hardened, continental architecture. Every minute of play is processed and defended by a system built to survive the most severe digital threats on the planet. When the final whistle blows, the physical stadiums will empty. The actual legacy of the 2026 World Cup will be the AI-driven continental blueprint it leaves behind for securing the next global mega event.